In this lecture, we'll be looking at the use of graphic calculator to solve binomial distribution questions. So let's get started. So what will you learn in this lecture? Well, you'll learn how to use Binomcdf to find p of x equals to x, how to use Binomcdf to find p of x lesser than or equals to x, and to use the table method to find n mod x and so on. So let's take a look at them. Let's start off with finding p of x equals to x using the function Binomcdf in your graphic calculator. Alright, so if you are interested in finding p of x equals to x for a binomial distribution, then what we need to do is to go to distribution. So distribution is in blue, right? So we press second followed by vars to go to distribution, and Binomcdf is at the back, so I press up. Then you see here Binomcdf is A, so I can type A here, okay, which is here followed by my A, which is here. Okay, so now I'm at Binomcdf. So in Binomcdf, right, maybe let me clear everything first. Okay, so for Binomcdf, right, what you need to do is to type in the trials, the p, as well as the x value. So trials refers to your n, p refers to whatever the p is, the probability of a success, and x, okay, when you want to find the probability, you type in a value. So for example, you can type in values like this, then you type paste, then press enter again. You get the probability of p of x equals to 2, which is 0.3087. Then round off to 3 significant figures is around 0.309. So now let's do part 1 together. So what we need to do is to go to distribution. Okay, go to Binomcdf, which is A. So I'll put alpha math. Okay, so now I'm at Binomial PDF. So now n, which is the number of trial, is 8. Okay, my p is 0.3 and my x value is 0. Okay, type it into the calculator, click enter again, and I will get my p of x equals to 0, which is 0.057648, and when I round it off to 3 significant figures, it will be 0.0576. Alright, so for part 1, let's write out the answer. So part 1, p of x equals to 0 equals to 0.057648. Always write 2 significant figures more than what you need. Okay, then round it off to 3 significant figures unless otherwise stated. So this will be how you present the answer for part 1. Next, let's go on to find p of x equals to 3 for the binomial distribution where n is 8 and p is 0.3. So to do so, go to distribution. Then next, I will go to Binomial PDF. Okay, so n is 8, p is 0.3, but now x is 3. I'll press paste, press enter, enter again. So I'll get the answer, which is here. Alright, so to find p of x equals to 3, so the answer is this, right? I need to write, I need to give my answers to 3 significant figures finally, but before that, let's write 2 more significant figures. Just copy 2 more significant figures, then round it off to 3 significant figures. So that would be your answer for part 2. In this section, we'll find what is p of x lesser than or equals to x using the Binomcdf function of your graphic calculator. Alright, so in order to use the Binomcdf, right, your probability must be in this format, p of x lesser than or equals to x. This is because they have written the code for Binomcdf to calculate p of x lesser than or equals to x only. Okay, so that is why if you do not have p of x lesser than or equals to x, then you need to change to get this. Okay, so now coming back to this, so the first step whenever you want to use Binomcdf is to make sure that you have the probability in terms of p of x lesser than or equals to x. Okay, if not, you need to convert. So I've given some conversion. So if you have p of x lesser than m, okay, so lesser is not lesser than or equals to, so you change it and so on. Okay, now once you have changed it to p of x lesser than or equals to x, then you can go on to your graphic calculator to find the probability. And so let me show you on the graphic calculator how to do so. So to go to Binomcdf, so like all your statistic functions, right? Later on, normal distribution as well. You press second, followed by vars to go to distribution. Then Binomcdf, it's right below Binompdf, okay, which is B. You can use your arrow to go to B, or you can simply just type B with your graphic calculator to go there. Okay, so now once you go to Binomcdf, remember Binomcdf is p of x lesser than or equals to x. So you have done step 1, right? Before you use Binomcdf to make sure that it's p of x lesser than or equals to x. Then you type in the trials, the p value and the x value and press paste. Then you will get the probability. Now that we have talked about how to use the graphic calculator to find Binomcdf, I want to talk more about the conversion to p of x lesser than or equals to x, which you need to do in step 1. So I give a lot of important results here, but I do not want you to memorize them. Okay, so instead, I want to show you how you can derive this by drawing a number line. So recall that when we have a binomial distribution, for example, p of x takes maybe 5, 0.3, what are the values that x can take? So x will always be an integer starting from 0 all the way to 5. So you take 0, 1, 2, 3, 4, and 5, right? Okay, so first thing you need to know, x, this is a discrete variable. So it has a finite number, and for a binomial distribution, right, your x always takes integer, and it starts from 0 and goes to n, okay, whatever n is for the question that you're doing. Okay, so now let's take a look at this. So if I have x lesser than m, then x is lesser than or equals to n minus 1. So let me give you an example. So if I have x lesser than 3, then it will be x lesser than or equals to 2, right? I don't want you to do this way though. I want you to sketch a number line for now until you're very familiar. Okay? Okay, so now I know that x will be lesser than 3, right? So in other words, I know x starts from 2, right? So therefore x is lesser than or equals to 2. Let me erase so let me erase this portion here, and I want to go on to part 2. Okay, so now next, let's assume I'm interested in finding x greater than 3. So x greater than 3, it's here, right? So in other words, right, I know that I'm interested. So if I use this formula, straight away you'll say 1 minus p of x lesser than or equals to 3. Okay, but I don't want you to memorize because there are so many possibilities to memorize, right? You have 1 to 7 or sometimes even more. So if you were to use a number line, you know that I want x greater than 3. So x greater than 3 is here. So and I know that x takes whole numbers only and it stops at 5. So in other words, I know that this could be p of x equals to 4 plus p of x equals to 5. Okay, or I can take 1, which is the total probability, minus everything from 0 to 3, which is p of x lesser than or equals to 3. Okay, so you can derive it by drawing a number line. Okay, and when you draw a lot, right, after some time you don't even need to draw the number line, you'll get it automatically. Okay, so for now you can just draw a number line to get yourself familiarized with how to change it to p of x lesser than or equals to x. Okay, then if you have more than or equals to m, okay, Maybe let me erase this again. So now let's look at 3. So if I have, for example, p of x greater than or equals to 3. So I'm interested in p of x greater than or equals to 3, right? So let's do it this way. So I am interested in 3, 4, and 5, right? So you can also write that is p of x equals to 3, 4, and 5. But there's a lot of typing into your graphic calculator, right? You must use Binomial Pdf 5, 0.3, 3 plus Binomial Pdf 5, 0.3, 4, and so on. Very tedious. We try to minimize typing because time is a limited resource for your H2 exam. Okay, so what you'll do is, okay, I need to go from 3 to 5, right? That means I'll take 1 minus lesser than or equals to 2. So 1 minus p of x lesser than or equals to 2. Okay? All right, next, let's look at other examples when we have in between. So there are so many in betweens, right? You can have in between but not inclusive of, or you can be inclusive of one, not inclusive of the others, and so on. Okay, so I'll go through these 4 examples using the number line. Okay, reason why I keep going through with the number line is because I don't want you to memorize. It's just too many to memorize. So what I want you to do is to be able to change it into p of x lesser than or equals to x by maybe sketching a number line. Okay, or after some time it just comes naturally to you. All right, so let us use another example. So I'll erase this as well. Okay, maybe okay, so now we still have the same example, p of x. So we have a binomial distribution 5, 0.3. Okay, but even if it's not 5, it doesn't matter. So now I want to look at maybe x is in between 2 and 4. So I'll write 2 and 4. I don't want this. I don't want this. I only want what is in the middle, right? So you notice this is basically p of x equals to 3. Okay, right? Okay, so you can actually do it this way. So by drawing, you know that, oh, it's basically p of x equals to 3. What if I have x in between 1 and 4? Same thing, I'll draw 1 and 4. I don't want to include 1. I don't want to include 4. So that means I start from 3, right? Okay, 2. So it's basically p of x equals to 2 plus p of x equals to 3. Or if I want to use binomial CDF, that means I want everything. I'll take this, then minus this. So I'll subtract this away. So it can also be p of x lesser than or equals to 3 minus p of x lesser than or equals to 1. Okay? Next, I want to go through example 5. So let me erase all again. And this time I want to use maybe another example, another binomial distribution. Maybe I have b of 20 and 0.2. Okay, so now let's look at 5. So let's assume that I'm interested in x is in between 6 and 15. So now I know I don't need 15, so I start from 14, right? So I'm interested in 14. Then I want to include 6. So it's basically from 6 to 14, right? So I'll draw the number before that. So I want to take everything 1. So I'll take this. So I'll take p of x lesser than or equals to 14 minus, because I want to include 6. So I don't minus away 6. So I'll minus p of x lesser than or equals to 5. All right? Okay. Next, let's look at 6. So when x is in between m and n, and you inclusive of n. Okay, you notice that once you draw the number line, right, it gets easier. So let's have maybe x takes binomial distribution 30.2. Okay, then I'm interested in p of x in between 10 and 22. So now I know from the number line that I want to include 22. Okay, so I'll start from p. So I will definitely take p of x lesser than or equals to 22, and then I minus, I don't want 10, right? That means I want to start from 11. Okay, so I will minus 10. So I'll subtract this away. So I will minus p of x lesser than or equals to 10. Okay. Then let's look at the last one, number 7, when you have x in between and inclusive of both m and n. Okay, so let's use an example. For example, I have x in between, x takes binomial 50, 0.1, and I'm interested in x in between 5 and 35. Okay, so what I'll do is I'll first draw 35, and I know it includes 35, right? So then I'll put in 5, and I will also put in 4 and also 6. And I want 5, right? So if I want 5, I will not subtract 5 away. I will subtract p of x lesser than or equals to 4. So I will take p of x lesser than or equals to 35 minus p of x lesser than or equals to 4. Okay? So this is how you do a conversion to p of x lesser than or equals to a certain number. Then once you have convert all of them to lesser than or equals to, then you can type it into your graphic calculator. Alright, so in part 1, you are asked to find p of x lesser than or equals to 3. So based on step 1, alright, so in part 1, you are asked to find p of x lesser than or equals to 3. So based on step 1 of using Binomcdf, you need to make sure that it is lesser than or equals to. And because we have lesser than or equals to, so we don't need to do any conversion, we can straight away type it into your graphic calculator, right? So go to distribution by pressing second followed by vars. Then go to B, which is Binomcdf. Okay. Then now I have n equals to 8, p equals to 0.3, and x equals to 3. Press
Okay, so we have
paste.
p of x lesser than or equals to 3 being 0.80589. Copy 2 extra significant figures and then round it off to 3 significant figures, which is 0.806 when rounded off to 3 significant figures.
Okay, so let's look at part 2. So we are interested in p of x lesser than 3, right? So for p of x lesser than 3, okay, so this is 3. So I want p of x lesser than 3. That means I want to start from 2, right? So it's equals to p of x lesser
Now let's
than
use the
or
GC
equals
to
to
find
2.
p of x
So
lesser
now
than or
that I've
equals to
changed it
2.
into
To
2,
do
so
so,
we
you
press
press
second
followed
followed
by
by
can use the
vars to
graphic
go to
calculator to
distribution.
find the probability.
Then go to B, which is Binomcdf. Okay, so n is 8, p is 0.3, and x is 2. Press paste. Okay, press enter, and I'll get my answer. So I'll copy 0.551773. So round it off to 3 significant figures, I'll get 0.552. Now let's do part 3, p of x greater than 4. So if I draw the number line, I know I want 4 and beyond, but not including 4. So in other words, I want to find 5, right? So from 5 onwards. So in other words, it will be everything minus, so it's 1 minus p of x lesser than or equals to 4. Okay, because I don't want everything here. And the total probability is 1.
Now that we
So
have
I'll take
changed to
1
x lesser than or equals to
minus
x, we can
p
find
of
the probability using the
x
calculator.
lesser
So we
than
want to
or
find
equals to
1
4.
minus p
So
of
now that
x
I have
lesser than or
changed
equals to
to
4. So what we will do, we
x
will
lesser
press
than or
1
equals to 4, I
minus,
can
then
use
go
my GC
to
to find
second
the
bars.
probability.
Okay, then look for Binomcdf, which is b. Okay, so I've n equals to 8, p equals to 0.3, and x equals to 4. Press paste. Okay, so now I have 1 minus p of x lesser than or equals to 4. Press enter again. Okay, and I'll get the answer.
Okay, so I'll copy 2 more significant figures than what I need. So it will be 0.057967. So when round off to 3 significant figures, will be 0.0580. Now let's do part 4 together. So we have p of x greater than 4. Greater than or equals to 4. So p of x greater than or equals to 4. So if I draw the number line, I want 4, right? So I'm interested in 4 and beyond.
So
And
we
I
want
do
to
not
find
want the
1 minus
rest. So I
p
do
of
not
x
want
lesser than
anything
or equals
starting
to 3
from
using
p
the
of
graphic
x equals
calculator. So
to
type 1
3.
minus,
So basically
and
it's equals to
then
1 minus
go
p of
to
x lesser than or
second
equals to 3.
vars. Then
Okay?
Binomcdf, which is b. Press so we need 8, 0.3, and 3. So I'll change the x value to 3. Press enter. And here we go, we got the answer for p of x greater than or equals to 4, which is also equals to 1 minus p of x lesser than or equals to 3.
Okay, so round off to 3 significant figures, it will be 0.194. Alright, let's do part 5 together. So we have p of x greater than or equals to 1, right? So if I draw the number line, I'm interested in 1 and beyond. Okay, so that means I'll take the total probability, which is 1, minus what is before 1. So remember that the binomial distribution starts from 0, right? There is no value smaller than 0. Basically, if I want to subtract 1 minus p of x lesser than or equals to 0, it is basically 1 minus p of x equals to 0.
Now we are
Because the
interested in
binomial
1 minus
distribution,
p
the
of
x value
x
starts
equals
from
to
0.
0. So
So
because we have
if
x
x is lesser
equals
than or
to
equals to
0,
0,
so
the
we will be
only value
using
that x can
PDF.
take
Okay,
when
binom
it is lesser
PDF.
than or equals to
So
0 is
1
0. So
minus, let's go to
it is
binom
basically
PDF by
p of
pressing
x
second
lesser than or
followed by
equals to
vars to
0
go
is
to
basically p of
distribution.
x is equals to 0.
And then
So
A is
now that
binom
we have it
PDF. So let me
as p of
go
x
to
equals to
A.
0, okay, we can use
So
the
I
graphic
have number of
calculator to
trials
find the
being 8,
probability.
p being equals to 0.3. And I'm interested in the x value of 0. Press paste, press enter again, and I will get my answer.
Okay, so I'll copy 0.942 plus 2 more significant figures. Then I write it to 3 significant figures. All right, let's do question 6 together. So we are interested in P of X in between 2 and 4. So 2 and 4 and not inclusive of them, right? So between 2 and 4 is basically just 3. So if I don't include 2, I don't include 3 basically. I only include 3.
So
Sorry,
since we
if
are finding P
2
of
and
X equals
4
to 3,
are
it is a
excluded, then
binom
the only
PDF.
um,
Okay, so to do
probability
so,
that
we'll
I'm
press
interested in
second,
is
followed
P
by
of X
vars to go
equals
to
to 3.
distribution.
So next,
Then
let's
go
use the
to
graphic
Binomial
calculator
Pdf,
to
which is
find the
A.
probability.
Okay, we have n equals to 8, then p equals to 0.3, and x equals to 3. Press enter again, and you'll get the answer.
Okay, so I'll copy 0.25412, then round it off to 3 significant figures, 0.254. All right, let's do part 7 together. So we are interested to find P of X in between and include greater than or equals to 2 but smaller than 4. So if I to draw the number line 2, 3, 4, include 2, exclude 4, that means I'm interested in P of X equals to 2 plus P of X equals to 3. Okay, so with that, we can type this into the graphic calculator to get the answer.
So I'm interested in P of X equals to 2 and P of X equals to 3, right? So let's do it. So I'll go to vars. I'll go to distribution, then I go to Binomial Pdf because I'm interested in equals to, right? X equals to, so A. Okay, then I have 8, 0.3, and 2, right? So X is 2. Paste, paste again. So next, right, I am interested to add this value to P of X equals to 3. So I can basically um, do it by doing this thing. So I want to copy this, right? So I will go to, so I, uh, wait, let me clear it. So what I did is I use the arrow, go upwards. I'm not interested in this. I'm interested in this. So I want to enter it. Okay, press enter once only because what I want to change is I want to change the 2 to 3 here. Okay, so just press 3. So now I have, this will allow me to find P of X equals to 3. Okay, then I plus, this is P of X equals to 2, which we have just found. Just plus this. Press enter, then you'll copy it to here. Press enter again, and you'll get the answer. Okay, so this is the answer of P of X equals to 2 plus P of X equals to 3.
Okay, so you get 0.551 when rounded off to 3 significant figures. Of course, you can press binom, go to distribution and type binom PDF and so on. But right, I find that this way it's shorter because I don't need to, I press less buttons. Okay, so when time is limited, we try to find an easier way out. So if you need to use Binomial PDF again, right, when you have so much of it at the top, right, you just need to press the up arrow and then just copy it down, then just change. This is N, this is P, this one is X. Okay. All right, let's do part 8. Okay, so in part 8, we are interested in P of X, okay, P of X, okay, greater than 2 and lesser than or equals to 4. So if I look at the number line, 2, 3, 4, I don't want 2.
So for 8,
I
we are
want
interested in p of x
exclusive,
equals to 3
excluding
plus
2
p
but
of x
inclusive
equals
of
to
4.
4.
So I have 3
So
and 4.
because it's
So I have,
equals to, I'm
this is the
interested
same as
in
finding p
binomial
of x equals to 3
Pdf.
plus
So
p of
go
x
to
equals to
distribution
4.
by pressing
Okay,
second
so now
followed
with
by
that, I can
bars.
type it into the
Then go
GC
to
to find
Binomial
the
Pdf,
answer.
which is A. Okay, then I know n is 8, p is 0.3, and I'm interested is x equals to 3. Okay, go to paste, enter. Then I'm going to go here again, press enter so that I copy it. Okay, then I'm going to change this value here to 4, right? Okay, then I'm going to add the previous answer, which is here, press enter. Okay, then press enter again and I'll get the answer.
Okay, so I'll have it being 0.390 when rounded off to 3 significant figures. Next, let's look at part 9, where we are interested in p of x in between, greater than or equals to 2, but smaller than or equals to 4. So I'll write 2 and 4 again. Now I include 2 as well as 4, right? So what I can do is I can, it is equals to p of x equals to 2 plus p of x equals to 3 plus p of x equals to 4. Or I can also take p of x equals p of x lesser than or equals to
So now we
4
are interested in p of
minus
x lesser
what
than
is before
or
2,
equals
which
to
is 1,
4
right?
minus
P
p
of
of x
x
lesser than or
lesser than
equals
or
to
equals to
1.
1. I
So
prefer this because I type
because it's
less
lesser than or
things,
equals to,
okay?
we'll use
But both will give you the same
Binomcdf,
answer.
okay, which is
So
B.
it will
So
be
go to
p of
B,
x lesser than or equals to 4
okay,
minus
n
p of
is
x lesser
8,
than or equals to 1.
p is
So now I can type this
0.3,
into the graphic calculator to find
and
the answer.
the x value is 4, right? So I'll take 4 minus, okay, so enter. Okay, then I want to take this answer here minus p of x lesser than or equals to 1, right? So I will copy this down. Okay, then I'll change this 4 here to 1. Okay, press enter to get the answer.
Okay, so I have 0.687 when rounded off to 3 significant figures. Next, let's look at how to use the table method in the graphic calculator to find unknowns like n, mode, and x.
Okay, to use the table method, right, to find n, mode, and x, okay, to do so, you'll first press y equals to on your GC. Okay, then depending on the equation that you have, for example, maybe we have p of x equals to x, so therefore we will use Binomial Pdf if it's a binomial distribution. Okay, oops. Okay, then for example, then next, right, once you are in the distribution area, right, leave what is unknown as x. So for example, if the x value is unknown, you will keep the x as x. Okay, if the x value, so if the x value is unknown, you will press x for the x value. Okay, if the x value is known, but instead what is unknown is the number of trials, then write this as a variable. So press this button here. Okay, so then once you are done, okay, so maybe what I'll do is maybe I'll just put it as this, and I put x value here as the unknown. So once you're done, go to paste, press enter, and you'll go back to your y equals to again. Okay, then press enter again. Then I want you to go to your table. Okay, your press second followed by graph. You'll go to the table. Then you notice for the different values of x, this is what your probability is. Okay. In this question, we are given x takes binomial distribution 5, comma 0.3, and we want to find the mode. So when we want to find the mode, right, we do not know what is the value of x that will give the highest probability. So we want to find p of x equals to a maximum. Okay, so the x value is the one that is unknown. So to do this question, we will first go to y equals to. Okay, next I'm interested in p of x equals to x. So it will be a binomial PDF. So I'll press second followed by distribution. Then I go to binom PDF, which is A. Okay, now I know that the number of trials is 5, p is 0.3, and the unknown is x value. So I'll put my variable, which is x here, as the x value. Go to paste, press enter again. Next, I'll go press second followed by graph to go to table. Okay, then, oops. Okay, wait, let me go back to table. Okay, so this is the table. So remember for your binomial distribution, right? As x, so x starts from 0, and when x increases, right, the probability will increase until it reaches the highest value, then it will start to decrease again. So by looking at x equals to 0 is 0.16807, then it becomes even higher, 0.36015, then it starts to drop. Okay, once it drops, the rest will be have a lower probability than this one here. So based on this table here, we know that the mode is x equals to 1. Okay. So now that we have gotten these values, right, from the graphic calculator, and we know that x equals to 1, how do you present your answer? Well, first you will need to draw a table. Okay, so you first write from GC, then what we do not know is the x value, right? So you write x, then the other portion here is p of x equals to x, because here refers to x and here refers to p of x equals to x. And we know that the mode occurs at x equals to 1. So what you need to do is you copy the one of the values before it and one value after it. So you need to copy x equals to 0, 1, and 2 and their corresponding probability. And then conclude that hence mode occurs at 1. All right. Let's look at example 2. So where n is the unknown. So we are given that y takes binomial distribution n, 0.1. So we are asked to find the minimum value or the least value of n for which p of y greater than 0 is more than 0.99. Okay. So in other words, right, we are interested in p of y greater than 0 being greater than 0.99. Okay, but we know that if we want to use the graphic calculator, right, we either have p of y equals to something if we use binomial PDF, or p of y lesser than or equals to a value if you want to use binomial CDF. So since we have y is greater than 0, so this is y, right? So this is 0, 1, and so on. So we are not interested in 0. So basically, what we are looking at is 1 minus p of x. Sorry, p of y equals to 0, right? The only thing we need to exclude is 0. Okay, so we will change this p of y greater than 0, which we can use the GC because it doesn't have greater than, to 1 minus p of y equals to 0 greater than 0.99. Okay, so once we have this, we can use the graphic calculator to find the value of n. So to find n, what I'll do is I will go to y equals to, next I will take 1 minus, okay, because I'm interested in 1 minus p of y equals to 0, it will be 1 minus binomial PDF. Okay, so I'll go to binomial PDF. okay, which is A. Okay, the number of trials is unknown. So now I put this as X. P is 0.1. And X is equals to 0 because I am interested in P of Y equals to 0. Now I go to paste, press enter, then go to the table and slowly go through these values of n such that the probability is greater than 0.99. So we'll scroll down slowly until we reach a value that is more than 0.99. Okay, we are still at 91, so we are reaching 99, so it's going to increase. Oh, so you notice at 44 we reach more than 99. So this is what we get from the graphic calculator, and we know that when n exceeds, so starting from n equals to 44, the probability of 1 minus py equals to 0 exceeds 0.99. So to do this, what we need to do is we need to copy a few values, okay, and then conclude that the minimum value of n is equals to 44. So write from GC, write n. So your answer is 44, right? So you copy 1 before it, which is lesser than 0.99. Okay, then write, copy 44, which is our answer, and copy 1 after it, which is 45. Okay, then conclude, hence minimum value of n equals to 44.